Welcome again to the DevFest of this year. This talk will be about the badge ZooKeeper. Especially I will introduce you some methods to implement the leader election and use this leader election for an automatic failover in your IT infrastructure. I'm Rene Schakmann, I'm a developer at Willhaben. We have two other Willhaben guys here, it's Stefan and Thomas. So if you have any questions, you can come to me or to these guys.
So you are looking for developers?
Of course we are. So just to one of us and feel free to ask any question you want. What I'm going to cover in this talk is the basics of a badge ZooKeeper. What is it? Because most people have heard of it because some tools, some database is using it. But most people do not know what it is exactly and how it works. I'm going to give you some context when to use ZooKeeper. As Sigi already mentioned, ZooKeeper may not fit your requirement, may not fit your IT landscape if you're a very small company and do not have the functional requirements or the non-functional requirements to implement an infrastructure component like ZooKeeper. I want to show why you should use ZooKeeper if you have one of these requirements that I'm going to cover, and of course I will show you how you can implement things like the failover or the leader election or some simple other stuff. I want to give you a short introduction to the environment I'm working in. So what is the volume of requests we have every day, because I think that's important. Infrastructure components like ZooKeeper add an additional layer of complexity to your IT landscape. So if you really do not have the need for that, because you're a very small company, you should probably not use it. I think most of you guys know Willhaben. What most of you don't know is how big the infrastructure actually is. And that Willhaben is one of the largest internet sites in Austria. We have over 100 servers, including physical machines and VMs up and running that need to be coordinated to serve a lot of requests every day. These servers include our test environments, but most of them are for production. We are sending over 1 million messages a day. These messages including emails you get, like search agents and stuff like that, or if someone wants to buy something from you, and push messages that you get on your Android phone or your iOS phone. We have over 1.4 billion page impressions a month. If you talk about page impressions, you always have to mention the source. In this case, it's the Österreichische Webagentur, because everyone message the page impressions in a different way. So it's quite a huge environment I'm working in. As usually, if you have a website up and running, you don't have a smooth traffic like all the same all the day. So you have up and downs, and you really have some peak traffic at some points at a time. And if you have an environment like this, and then you have at least a couple of tens of batch jobs up and running, that also add some peaks at the load to your servers. This is one of our dashboards. It shows when we are sending out push messages to you guys. So if you have a search agent on our platform, then you get notification if someone adds actually something that you're looking for on our platform. What you see here is that we're sending these messages to you at certain times of the day. And what is important here is that people are actually used to get the push messages at a certain time of the day. And we use ZooKeeper to ensure that these messages are delivered at the same time every day, even if there is an outage of one service or something happens in the infrastructure. So we can do the automatic failover to another VM, to another machine, and ensure that the messages will be delivered at the time. And believe me, if we would not do it and say, okay, it's fine that the messages are 1 hour late or 2 hours late, then people are going to call us and say, hey, I don't get the message. So it really depends on your business model, and how you define customer satisfaction if you need things like automatic failover and what they can tolerate of failure in your infrastructure. Going to what actually is a batch ZooKeeper. As I mentioned, most of you know the name. They know that it's somehow some infrastructure component where you can do some stuff in distributed systems. You know that this maybe that you can use it for Apache Kafka or something like that, but how it's actually working, I think that's one point that we need to figure out in this presentation. So ZooKeeper itself started as a sub-project of Apache Hadoop, and now it's a top-level project for a couple of years. It's version 3.4.9 right now, and it's a pretty mature project right now. So we have it in production for 1.5 years now, and I think there were no errors whatsoever related to ZooKeeper or no outages of the ZooKeeper cluster at all. So it just runs. It's infrastructure component like your database, or if you have ActiveMQ up and running, or network equipment, it's just there and it just works. And the maintenance cost is pretty low. So we set it up once and then it's just running forever. Currently they're working on version 4. The first version 3 was actually published in 2008, so they're pretty slow in development of major versions, but they keep I think 3 to 4 minor updates every year, so there is an active development of this project. That's the official definition of Apache ZooKeeper. So it's a pretty abstract definition what it does. It's an open source server to build reliable distributed systems. I think this abstract definition is something why most people don't know what it really does, because you can do a really wide range of different features all over the place using Apache ZooKeeper. These are some projects that use Apache ZooKeeper. As I already mentioned, Kafka. I don't know which of you guys know Kafka. Kafka is some messaging broker service, one can say, like ActiveMQ, but it's faster and it's a little bit different what you can do and what you can do actually with that stuff. And Kafka uses ZooKeeper for the internal cluster coordination. So it stores there, for example, the offset of different customers, so which messages have already been read by a certain consumer, and where is the offset in the log. Solar is a search engine like Elasticsearch. Solar itself, you can deploy it as a cloud cluster infrastructure, so then you can partition your index of your search documents and so on. If you do that, then Solar Cloud uses Apache ZooKeeper for internal cluster coordination as well, like Kafka does it. HBase, I think most people know, storage for a massive amount of data, so billions of rows of data. Also uses ZooKeeper for configuration management, as Apache Hadoop does, and Akka is a framework for building event-driven, distributed Java applications. It also uses Apache ZooKeeper to coordinate different instances of the programs. So what can you actually do with Apache ZooKeeper? I want to start with some very simple examples. Every one of you, I think, or most of the Java guys at least, have written some synchronized method. So you have multiple threads, and you don't want multiple threads to access the same resource at the same time, because then you can have some weird behavior of the application and lose data or stuff like that. In Java, you can use the synchronize statement to avoid this. So only one thread at one time can enter this method, because it's locked on the instance of the class. This synchronized method just works inside the GVM actually. So you can do synchronized across multiple instances of your application. And even more, you can do a synchronized across multiple machines. Apache ZooKeeper provides a mechanism to do exactly this in a distributed manner. You can have logs using Apache ZooKeeper in your cluster, so you can share resources across multiple instances of application, and you can have a log. And this log is distributed. So this can be used in a very, very easy way, quite similar like the synchronized keyword, and it ensures that your code is working properly even if you have a distributed application. Who've worked in the Java environment knows that the synchronized keyword has some drawbacks. One of the major drawbacks of synchronized keyword is you can go into a deadlock, for example. And why is it? Not only because you're locking the resources in the wrong order, but the synchronized keyword never times out. So if it's requesting the access to a resource, and this resource will never be available, then you will never ever get the lock for this resource, and you can't go on in your program. A reentrant lock actually solves this kind of problem. You can request the lock for a resource, but it can time out. So you can say, I'm waiting 10 seconds, and after 10 seconds, please just throw me an exception, and you can go on in your program, so you don't deadlock your program. In Java, you can do it with the reentrant lock, and such feature is also provided by ZooKeeper. So you can do a reentrant lock across multiple instances of your application and across multiple physical machines. Another feature of Java, most of you guys know if you are programming some multi-threading stuff, are atomic values. So if you are, for example, you have a counter and you're incrementing this counter, and this special operation like E++ is not atomic. If you're accessing this variable from different threads, then you can actually lose some incrementation. To prevent this, Java provides atomic values. Atomic values guarantees that if you increment the counter, that you're never going to lose information, and that you can access one counter from multiple threads. Atomic values are also provided by ZooKeeper, so you can have a counter that is shared across multiple instances of your application. Some other very, very cool features you can use Apache ZooKeeper for example, configuration management. What we normally do, you have your application properties file, your application YAML files, they are checked into your repository. Maybe your operation has a different repository to override your settings, but at least these application files are files. So if you have multiple instances running of the same application and you want to change, for example, a batch size of something, then you have to change this value on 10 different servers. Apache ZooKeeper provides you a mechanism to store this information, these properties on Apache ZooKeeper, and this application are loading their configuration from the Apache ZooKeeper cluster. So you change it once, and all application or instances of the application just go to the Apache ZooKeeper cluster and get the updates. And you can do the updates in real time. So if you date it up, you don't have to restart your application as you normally have to do using application property files, for example. Queues are just another data structure you can use in Java. There are different implementations, and but there's no distributed queue. So you have multiple instances running, and they cannot share a queue. You can use ActiveMQ, RabbitMQ, something like that to have a queue feature for your application, but that's just an infrastructure component you add, and it's somewhat different than just having some queue in Java. ZooKeeper provides a way to do distributed queues in a very, very native way. You can have, as I already mentioned, shared counters. You can have a leader ledge. A leader ledge is something like a leader election. A leader election is you have two instances running, and one is the leader and does, for example, the work. A leader ledge is you have two equal services up and running, and each of the services is starting to do some work. and at the point it's starting to do the work, it goes to ZooKeeper and says, I'm allowed to do it, and then ZooKeeper says, okay, you're allowed to do it, and he gets the ledge. And the other service maybe starts at the same time, but ZooKeeper says, no, the other one is doing it. So it's a little bit different than leader election, but actually it does the same. And furthermore, you can do a lot of other logs like multi-phase logs and all that stuff. And it's a pretty native implementation using ZooKeeper. Most of the stuff I mentioned right now is implemented in the Apache Curator framework. Apache ZooKeeper itself just provides the infrastructure to do something, and it's very simple and very limited in what it provides to you as a feature itself. With these features provided by Apache ZooKeeper, there are some recipes like the logs, like the queues, like configuration management, like a leader ledge you can do. And these recipes are implemented for you in the Apache Curator framework. You can just use it out of the box, and it's working pretty well. So if you're looking for something like that, don't implement it yourself, go there, check it out. There are a lot of features in it, and just try it out. But be aware, maybe it does not fit your needs. Like the leader election in Apache Curator, we figured out that at a point 1.5 years ago was not as good as in dealing with network errors as we wanted it to be. So we took the concept of this leader implementation, of this leader election, implemented it on our own to just cover the additional cases we figured out that are important dealing with errors in our network environment. Spring. If you're a Java guy, you know Spring, and you know Spring Cloud, for example, and Spring Boot and all that stuff. I just want to mention it here because the integration of Apache ZooKeeper in the Spring environment is pretty cool. You can use the ZooKeeper, for example, for service discovery. So you must imagine that you have up and running 100 services, and the services all have a name, and you don't want to wire the services with using DNS names or IP addresses, because it's very difficult to maintain that stuff in your data center. So you can do a service discovery, like a UDDI directory in the old days. Then you can use it, for example, for client-side load balancing. So I don't know who of you guys know the Netflix open source stack. Normally a load balancing is done on a load balancer. So I'm the client, I go to the load balancer decides where to go. Depending on your infrastructure, the load balancer can be the bottleneck. So you can do it on the client side. The client gets all the available nodes, and the client can decide, for example, on random basis, to which client he can go and get the data from. Using Apache ZooKeeper, as I said, you can do the service discovery, and all services are registered there. So I'm the client, I can get all the services that are provide the same functionality, and then I can decide, okay, I go to this one, and the next time I go to this one, and I can do automatic failover, because if the first one does not work, I just go to the second one. Zool is dynamic routing. It's not so important, but it's also supported with Spring. And as I mentioned, you can do distributed configuration with the Spring Cloud. It's pretty abstract stuff right now, but as I mentioned, it's really simple. You can just have a look at the ZooKeeper stuff, and then you see that, for example, the marked node is just one application that is registered there, and to this application there are just key value pairs stored. So you can look at it, okay, so we have a test ZooKeeper application, it has a D, it runs on this server and on this port, and actually if you want to do a service discovery, that's pretty all you need. And if you have more than one entry, you can do the failover on the client side. So it's pretty straightforward, and it's not some sophisticated stuff, it's just a directory to look up other services. If you're talking about distributed systems, you always have to mention somehow the CAP theory. If you have a distributed system, you always have to make a trade-off between the consistency of a system, the availability of a system, and the partition tolerance of a system. So the drawback of such a distributed system is you can't have all of it. You can pick two. ZooKeeper is going to pick the consistency and the partition tolerance. and not the availability. So if a majority of your ZooKeeper nodes are breaking away, you're not able to get any information out of it. Just to give you a clue where other systems are in this area. At first, it's not that you have to choose exactly between all of the threes. It's not black and white. There are some grades between, so you can have a little bit more of this and a little bit more of this, and you can just put it together like you wanted to. For example, a typical Cassandra cluster is more on the availability side and partition tolerance side. A typical normal versional database is consistency and availability. And HBase and CouchDB are normally on the bottom of such a case theory. So, going to Apache ZooKeeper to actually how you set up your cluster. If you have Apache ZooKeeper, you don't have one node of ZooKeeper running. Normally you have at least 5 nodes up and running. Why you have 5 nodes up and running is because you want at least 2 servers to be able to go out of work. And if you have 1 server, you have no backup whatsoever. And Apache ZooKeeper always needs at least half of the servers that are in the cluster plus 1 to be a functional cluster at all. So if you lose more than half of the servers, you are out of order for as long as it takes to get the other servers back online. Apache ZooKeeper works this way that you always have one leader. You have a leader that is responsible to provide you some guarantees. I will mention the guarantees later on. So each server has all the information, but one server is for the coordination for specific stuff. The client connects just to one node of the cluster, and the cluster organizes just the routing of the stuff you want to know from the cluster. Each client is connected to the cluster, and it has a heartbeat protocol. So the cluster knows at every time how many clients are connected and are they alive. This is very important for specific functionality we will see later. And the connection is always stateful, so it's not an asynchronous stuff, and you don't have some stuff that reconnects all the time. So you have a stateful connection, and this there, it has to be there, and without it's not working. So consider it if you're connecting a huge amount of clients to your Apache ZooKeeper cluster. And Apache ZooKeeper is optimized to read performance. Even you can use it for heavy write loads, it's optimized for read, and it performs really, really well on reading a lot of data from the ZooKeeper cluster itself. So it's not a data store. You're not supposed to store any data in there, like images or, I don't know, customer data or stuff. It's really more for the coordination of different services. And normally you say it's about 100 kilobytes. That is the maximum of a message you're sending in there. One word to setting up your actual hardware infrastructure. If you go to your data center and you have one rack and you put all your ZooKeeper servers in one rack and you're connected to one switch, and this switch dies, you are completely out of business. ZooKeeper, as I already mentioned, is an infrastructure component, so it must be installed in your data center very, very carefully. So you have to split the servers across different racks, connect to different switches, and so on, that you minimize the possibility that the majority of your nodes go out of business at the same time. Because if you lose ZooKeeper, it's like losing your database. The application can't communicate anymore, and then they're doing nothing at all, and you are just out of business and nothing is working anymore. So please keep that in mind. So if you're going to implement it in your company, please go to your operations team and say, consider this if you're installing your ZooKeeper cluster in your data center. This was the hardware side. Going back to the actual software side. How is the data structured inside a ZooKeeper? Actually, you can say that the ZooKeeper cluster structures the data somehow like an hierarchical key value store, like a file system. So you have a root node, and you can make a node. In this case, it's not a physical node, it's a node of a tree structure. you can have different nodes, and the nodes can have children, and so on and so on. So it's a tree. As already mentioned, keep it small. You can do up to 1 megabyte in one of these nodes, but don't do it. Just keep it small. Yeah. To the data structure itself, you can have the node. The node can have a name, and you can store data to each node. And the data in there is a key value pair. So how does it look like? I already mentioned it before. It's just like some JSON file, some JSON structure in there, so it's readable for us. So it's no binary protocol or something that is somehow not accessible for a human to read. And so it's pretty easy to debug that stuff as well. The nodes you can create are somewhat different than creating a folder on a file system. They can have different attributes and different behavior. You can create a normal node, so you create it, and it's just there. You can disconnect, you can reconnect, it's just sitting there and waiting. It's like you're creating a folder. You can create an ephemeral node. An ephemeral node has a really different behavior. I'm the client, I create it, I say this is an ephemeral node, I disconnect, and it's gone. So it's somehow a temporary node that lives as long as my session to the ZooKeeper cluster lives. So if I disconnect, it's going to be deleted. So don't store any data or any information in there that you want to keep persistent. Because if you have a network outage, you're gone. Then you can create sequential nodes. Sequential nodes are just nodes with unique names. Just imagine you have a prefix, and then ZooKeeper is going to add a number to it, and the number is incrementing. So, and you can combine the stuff. So you can have an ephemeral sequential node. The nodes in your ZooKeeper cluster are pretty simple. Like on a file system, you can do different operations on it. You can create it, you can delete it, you can check if it exists. You can get the data that is in the node. You can set the data, of course, that is in the node, and you can get the children, and you can do some syncing stuff. That's actually all you can do with ZooKeeper. So it's, as I mentioned, it's pretty easy stuff, but it's pretty powerful if you combine all the features together. ZooKeeper itself also provides some sort of permission handling, so you can set permissions for different actions you can do, like create, read, write, and of course you can set the admin permission, so you can do everything you want with this node. So if you are working in an environment where security is actually important for you, you can cover this using ZooKeeper, and you do not have to figure out some access schema on your own. So it's built in, you can use it, and it's production ready. And it's pretty simple as well. As already mentioned, the ZooKeeper cluster has a leader, and thus the leader relation itself, because it provides you some guarantees about the actions you do in the ZooKeeper cluster, or about the data you're writing in the ZooKeeper cluster. The guarantees are the following. The data that you're writing in the ZooKeeper cluster is replicated. So as you write data in the ZooKeeper cluster, and you get the feedback that is written there, then you can be sure that this data is written to the other nodes as well. So your data is safe. If you have an outage of nodes of the ZooKeeper cluster, your data is safe, and you don't have to worry about that maybe there would some background job running, synchronizing data, and you have some delay. It's not the case, it's there. The data you're writing in a ZooKeeper cluster is ordered, so it's called sequential consistency. If I'm writing something in it, and after that I'm writing something in it, it is guaranteed that this order is maintained. So it cannot be that the first action I write in there is somehow overwriting the second one. And this guarantee is not only provided for me as one client writing it in there, but it's also provided for all the other clients that are on a ZooKeeper cluster. So if I'm writing some events in some order in there, all other clients will get it guaranteed in that order. And that's why you have to have a leader, because you have to have one point in the system that guarantees that order. Another guarantee that you get is atomicity. If I'm writing data in there, ZooKeeper guarantees you that the data is written as a role, so as completely in it and not partially written in. So you can't get any inconsistent data. So if I'm writing a data node, it cannot happen that half of the data I'm writing in there is missing anywhere. It also guarantees you a single system image. What does that mean? If you have a distributed system, it could happen that you have different views of a system because different parts of the system can be in different states because of synchronizing stuff between the nodes. So I write one data to one node, and at this time, if I'm going to this node, then I have one image of the system. If I'm going to another node, and this node hasn't synchronized with the first one, I have another view of the system. ZooKeeper guarantees you that you always have the same view of the system. So if I have written some value there, it is guaranteed that everyone sees it, and not that, that you can have some updates from here and updates from here and they get somehow mixed up. It's always the same image and everyone sees the same. And the last one is that ZooKeeper guarantees you that all your updates, all your actions you're going to do on the ZooKeeper cluster are broadcasted to the clients and to other ZooKeeper nodes in tenths of a second. So it is guaranteed that there is no delay between some sending data there and others getting the data out of it. So you can be sure that if you write something, that there is no delay for a client to get the data and he has to wait, I don't know, 1 second, 2 seconds to actually get the updates. So it's pretty real-time, the system, and it's really, really useful if you're going into distributed systems, that you know that it's real-time and you don't have to have long delays to wait for. As I mentioned at the beginning, adding ZooKeeper or adding any infrastructure component at all to your ID landscape adds an additional layer of complexity. It's always a trade-off. If you add it, you get something out of it, but you have to pay a price. I want to give you one example. That's not ZooKeeper related, that's Java stuff, but it's one line of code and it does something. You can optimize this code. It's a Java stream, it's Java 8, Java streaming library. It's pretty okay, but you can optimize it. You don't want to optimize it as you have to. So if I give you the context information that I'm only calling this method once a day, I'm not going to optimize this code because you're getting the drawback that the maintainability of this code is bad, that you can actually have more errors in this code, and so on and so on. It's the same with Apache ZooKeeper. If you add Apache ZooKeeper to your infrastructure, you have an additional layer where you can get errors. And it's not only that you can get more errors out of it because you have this layer, but it's also very, very complex to find it. Because the errors you get are not only bound to your local GVM anymore, they can be somewhere in your complete network infrastructure. They can be on your local GVM, they can be on the ZooKeeper client, they can be in the communication, they can be actually in the coordination of your distributed system. So think twice before you're actually going to distribute the systems, before you're going to use an infrastructure component like that. Don't use it because it's cool, use it because you really need it. Check your requirements and check it if it's usable for your use case. So what are requirements that maybe lead to using Apache ZooKeeper? At first I want to mention non-functional requirements, like recoverability. Recoverability means the mean time to recover and to minimize this matrix. So if I have an outage of a server, if it fails, how long does it take me that this server is up and running again? Reliability of a system, so mean time between failures. How long is the typical time between one error and the next one? That's something I want to maximize. Fault tolerance. What happens if one GVM just crashes because of an out of memory, faulty data, whatsoever? Performance. Distributed systems are really, really related to performance, because why do I distribute a system? Because I want to work on data in parallel, I want to actually speed up to process my data. And I can speed up processing data, adding more machines and splitting up the data, or in each machine of it is working on only a part of the data. Other requirements, not on such a high level as on the last slide. If you want to have an automatic system recovery, one server fails, do you want your operations to actually have to go there and hack something in the PC that the service is working? Or do you want, you have one server running and another server and one fails and it just tells the other server somehow, just do my work? Zero downtime deployments. Zero downtime deployments are not only used, for example, for web servers, but you can only use zero downtime deployments for backend systems. Like I mentioned before, sending out the push messages we do at Willhaben for you guys. If we do it at the time frame where we are sending such an interval to you, like in the morning, and we do a deployment, we don't want this one wave of push messages to be somehow delayed. So our backend systems have zero downtime deployment as well, not only the web servers we are using. If you have time-critical tasks. And another important thing is you have service-level agreements. So if you're maybe a company building stuff for other companies, you normally have a service-level agreement which says your services have to be up and running at, I don't know, most of the time 99.999%. So if you're using ZooKeeper, for example, you can more easily guarantee such SLA agreements. And you can do, of course, other stuff like hot standby. I don't mean this hot standby. This hot standby is a typical hot standby of a typical web platform. You have a load balancer, you have some web servers behind it. 10 web servers behind it?
10 minutes.
10 minutes, okay. And if it fails, it just switches over to another server. I mean, some sort of this hot standby. You have two machines up and running. Maybe the services that start up need some initialization times, and one of the machines is the leader. It's automatically selected using ZooKeeper, and the other one is data processing. And if it dies, the other the other server just takes it over. This is really easier than doing, for example, partitioning. You can achieve the same with that. But if you have partitioning, you have to split the data up, and you also have to do some sort of rebalancing. So it's really easier to have some master-slave setup than do the partitioning stuff. And last but not least, do it for your operations. If you build a resilient system that has automatic failover, that does an automatic system recovery, you are not the guys getting the call in the middle of the night that some service has crashed and have to fix it, but the operation actually has to do it. So if you build the infrastructure like that, normally the operation guys are pretty happy because they have less work in the middle of the night. So all that stuff seems pretty easy, but you can implement it yourself. We tried it, we failed, really. You have to cover a lot of errors like networking errors, timeouts, high load scenarios. And you have actually to cover the conceptual side as well. So who is the leader? Yeah? Who do you select the leader? Is it the best hardware? Is it the fastest one? Is it based on the current load? So who is it? What happens if the leader dies? When do you start to do a failover? What happens if the leader just disconnects from the other service and is not from the database, so he actually can't do the work? What happens if you have a leader, you select another leader, and then the first leader reconnects? Then you have two leaders. That's the worst case ever. And what happens if the leader is just sitting there and is doing nothing because he has a deadlock? So going to the leader election, it's pretty easy. What we want to achieve is multiple instances of one program running in different GVMs, in different virtual machines or physical machines, and just one of these services should actually do the work, and the others just should sit there and do nothing at all. Hope you can read it, but it's pretty simple. And I want to be the leader, for example, and I connect to the ZooKeeper cluster. I check if there is some root node that is configured from my application, and then if it's not there, I will just create some root node so I can have multiple applications running in the same ZooKeeper class. So that's pretty easy stuff. After that, I'm going to create an inferral node. So remember, the inferral node will be a gun when I disconnect, and this will be a sequential node. So we'll get some sort of number behind my node name. And then I'm going to check. I am the smallest node in this folder. If I'm the smallest node, so if I have the lowest number, I'm the leader. If I'm not the smallest node, then I'm not the leader, I'm just a slave and I'm doing nothing. But if I'm not the smallest node, I'm not the leader, I'm going to watch the first node. If it's going to be deleted, I will do the same again and check I am the smallest node. And so you can pretty easy say, okay, you have one server doing the stuff, he's the leader, and this pretty simple algorithm based on this pretty simple ZooKeeper functionality, and it works pretty well. We have it up and running for 1.5 years now, and we never had 2 masters in production at all. So how does it look like on the conceptual side? It just, each node creates, as I said, the nodes in the ZooKeeper, and it just gets a number, and it's just a prefix and some number after it. How does it look if you actually do it? Yeah, pretty simple. It's not more than that. You have nodes and you just check who's the smallest. You can wrap this stuff away, we did it. You can find the corresponding code to this implementation I showed you here in our GitHub repository. So you can just check it out and use it. And that's just the basics behind the stuff, how the classes work together. Just to show you in a short way how simple it is to act with ZooKeeper. Doing a ZooKeeper connection, one line checking if a node exists, one line checking if a node exists, and I want to get the callback if it's gone, one line creating a node. Okay, here it's 3 lines, but actually it's 1 line, and getting all the children, 1 line. So it's no magic whatsoever, it's pretty easy, and it's really straightforward. If you're watching a node, you're just getting an event, and you can check what this event was. Did it disconnect? Was it deleted? All that stuff. So it's just one method, you can check the event, and it's pretty straightforward and really simple. So as already mentioned, you can get the code that is working, so you can start 2 instances and play around and switch it off and on again and see what it's going to do. On a GitHub repository, I will show you the location afterwards. It's a Spring Boot example, and it's ready to run. So you just need a ZooKeeper installation, and this is pretty easy as well. Just these 4 lines, and you have a ZooKeeper up and running. It's just one node at your local PC, but it's okay for testing around, and then you will get something like this. And you can just play around and switch one service off, and then you have 3 instances running, and just look how it behaves. Going to testing. Testing in the stuff I told you is a pretty hard thing to do, because you have really a high amount of components interacting there, like your PC, the network, the instances, the JVM, all that stuff. So if you're going to implement something like that, spend some time in testing, and it can be a pain in the ass. And actually you can't go to a data center and plug some cables there. But you need to do it. You need to actually check what happens if someone in the data center plugs a cable. What if the switch dies? Because that are the scenarios you're designing the stuff for. That are the thing you want to prevent, and in these cases your stuff must work. So you must test it. This seems like a toy. It's a Raspberry Pi cluster out of 36 Raspberry Pis. But if you don't have to build with 36, but even if you have 5, you can deploy 5 instances of your application, and you can go there and plug actually the cable. You can kill the switch, and so on and so on. So it's really helpful to have some mini small data center like we built here that will happen to test stuff like that. That was all from ZooKeeper for now. You can go to our blog. It's There's also an article about exactly this topic. You can find a lot of more information there. You can get the GitHub repository there. If you have any questions afterward this talk, you can write an email or just come to me. And thank you very much for your attention. If there are any questions, then please feel free.
Thanks, Rene. Who would be the first one? Yes.
I have a conceptual question about the leader election.
Okay.
So you said you have like 3 instances, and these 3 instances want to do some batch job. And so each of these tries to start his job and checks if he's the leader, right? Is that the concept behind? And asks ZooKeeper with your algorithm if he's the leader.
It depends. If you do a leader election, then the leader will be selected before you actually want to do some work. If you do a leader ledge, then you select the leader at the time you want to do the work. The difference is I'm starting up 2 services and you have 1 leader at the time you're starting it up. If you do a leader ledge, you have 2 services up and running, nobody's the leader. At the time you want to do work, you decide who is the leader. That's slightly different. We can do both. It's just what fits you best. Bitte?
You said that you also use ZooKeeper as a service registry. When would you use, for example, console in comparison?
We are actually not using it as a service registry because right now our infrastructure is not as complicated as that we need a service registry. Most of the time we just have 2 or 3 instances of the same service up and running. So we wire it on the hardware. But which stuff you actually use for service discovery, I think that depends on your other environment you have. So I'm sorry I can't actually answer the question for you.
Okay, so you have like 100 servers all running the same application, not like
No. We have 100 servers running different applications. So some of them are running the same, but not all. We have at least 2 servers running the same application because we need a backup. But we have, for example, our web servers are running 10 or 15 web servers the same application. So it depends on the load that you need to cover, how many instances are running, but at least 2. Because if you do a zero downtime deployment, you need at least 2. So sometimes the non-functional requirements like a zero downtime deployment are more important to have 2 servers than performance reasons to have 2 servers.
Do you have any experience with maintaining ZooKeeper with different data centers? Like I have one in Germany and one in Austria?
No, we maintain ZooKeeper installation just in one data center for us.
And do you know if ZooKeeper would work if the network latency is too high?
That's the last one. I can't answer that. We didn't try it out if there is problem syncing between data centers, I'm sorry.
But it does work with the 100 megabits Raspberry Pis, right? And I don't need gigabits.
It works on a 100 megabyte network connection.
Yeah.
Yes.
Sweet.
Yeah.
What do we actually store in ZooKeeper and in HAM?
We store, we use it for the Kafka. That stores the configuration and the configuration management in it. So that's, it stores the offset. I don't know if you know how the Kafka is working because it's complicated. It's very dependent on the application what is storing in there. So Apache Kafka is, it stores the messages that are in Apache Kafka like a log file. It's just append only. And if you're a client and you want to read a message, you are just like a pointer on the queue. And Apache Kafka, for example, stores this pointer in the ZooKeeper. So it's just an offset, it's just a number. On the other side, using like leader election stuff, you don't store any data there at all. You just rely on the actual node that is there, and the name of the node is is the important stuff, and that is gone if I disconnect.
I wanted to ask you, if testing with Raspberries proves to be sort of safe compared to the real environment, where I assume that you have some hardware and virtualization on it as well. Do the Raspberries cover everything, and do they behave the same way like for environments that are in production?
No, of course they don't. They don't. But there's always a difference between if you want to have it just the same in your data center, you have to build the data center just once again. But it's pretty expensive. So if you have some small little test bed like the Raspberry stuff, you can, as I mentioned, testing things like plugging the network cable, plugging the switch off or something like that, which you can do in a data center. So it gives you some clue about how your application is going to behave in scenarios you can test in a data center. But of course you have later on tested in the data center as well. But in a development stage, it's easier to go just to the next office room and standing there and plugging cables and turning Raspberries off and on than doing the same stuff in the data center. It's a question if you can do it. Nobody will allow you to go to the data center and plug a cable. You can try it once, but then you're on the blacklist.
How you were doing the lead election before you implemented ZooKeeper,
Okay.
and what's the main improvement now?
Okay. The improvement is that it works. No, I tried, and I failed. Implementing that stuff using some coordination, ActiveMQ based, but the latency there is just too high, and you always have the offset, and it's just not that real time as it seems to be. So it just didn't work. We had all possible error scenarios, 2 masters in there, no masters in there. It was, let's not talk about it. Any other questions? Okay, thank you very much.